Simple parity check method is based on parities. So let me first tell you how can we compute a parity of a given data unit. Suppose data to be sent is 1100001. How can we compute the parity of this data unit? To compute the parity of this data unit, we have to count number of ones in that data unit. As there are three ones in this data unit, we say the parity of this data unit is odd, because 3 is an odd number. For this case, there are 4 number of ones, and as 4 is an even number, we say parity of this data unit is even parity. In simple parity check method, only one bit is sent with every data unit for error detection. That extra bit or redundant bit is called a parity bit. Suppose the data to be sent is 1010111. Before transmitting this data unit, in simple parity check method, the parity is computed and it is made even. So as in this data unit we can say there are 5 number of ones. To make the parity of this data unit even, we will add 1 as a parity bit, and then there will be 6 number of ones. As 6 is an even number, the parity of this data unit is now even. So we say this is a parity bit or extra bit that will help receiver to understand or to detect an error in the received data. For this case, there are 4 number of ones. That means the parity of this data unit is already even. So in this case, 0 will be added as a parity bit to let the parity be even. So what does this mean? This means in simple parity check method, sender will send every data unit as a even parity data unit, and when receiver will see any data unit of odd parity, that will indicate that at least one bit might have been changed in the transmission, and therefore the data is corrupted or there is an error in the received data. For example, if this data unit is sent by the sender, and if suppose this bit is changed in the transmission or this bit is corrupted, what receiver will receive? Receiver will receive 10101110 because this bit is corrupted or changed. Now in this case, when receiver will count number of ones in the received data, there are 5 number of ones, and as 5 is an odd number, the parity of this data unit is odd parity. So odd parity indicates at least one bit must have been changed in the transmission, and therefore there must be an error in the received data. So this is the way in simple parity check method receiver will detect an error in the received data. To help you understand better, let me use a diagram and explain the concept better. In simple parity check method, there is a parity computer at the sender side which computes the parity of every sent data unit and makes a parity even, and then the data is transmitted. At the receiver side, there is a parity checker which checks a parity of every received data unit, whether it is odd parity or even parity. If the parity of received data unit is even, then only the data will be accepted, otherwise the data will be rejected. Let us understand the simple parity check method with this flowchart. Let us say data to be sent is 10101111. Before transmitting this data unit, it is given to a parity computer. Parity computer will compute the parity of this data unit, and as there are 5 number of ones in the data, one bit called a parity bit is added as one bit to make the parity of this data unit even. Now there are 6 number of ones. So the data unit now has even parity. This data unit, that is original data with a parity bit, is called a code word. It is called a code word, and the original data to be sent is called a data word. And then this data is transmitted to the receiver. So what is transmitted? The data transmitted is 10101111. If there is no error in the data transmission, we say receiver will receive 10101111. When receiver receives this data unit, it is given to a parity checker, and parity checker will check whether the parity of received data is odd or even. As in this case there are 6 number of ones, the parity of this data unit is even, and therefore this data passes the test and it will be accepted by the receiver. Let us now say how receiver will detect an error if the data is corrupted. For that, let us say sender sends 10101111, but there is a 1 bit error in the data transmission, and say this bit becomes 0. So what receiver will receive? Receiver will receive 10100111. When receiver receives this data, it is given to a parity checker, and parity checker will check the parity of this data unit. As there are 5 number of ones, the parity is odd, and when parity is odd, this data will be correctly rejected by the receiver, because we know receiver only accepts even parity data. Odd parity data will be assumed to be corrupted and it will be rejected by the receiver. So we say when 1 bit is corrupted, it is correctly rejected by the receiver, assuming there is an error. Let us now see how it behaves when 2 bits are in error. So let us say sender sends 10101111, but 2 bits get corrupted or changed during the transmission, and let us say this bit is corrupted and also this 0 becomes 1. 0 becomes 1. So receiver will receive 11100111. Now 2 bits are in error, right? So when receiver receives this data, it is given to a parity checker. Parity checker will compute the parity or check the parity. As there are 6 number of ones, the parity is even, and as the parity is even, receiver will incorrectly accept the data. Try to understand, as the parity of this data unit is even, and this mechanism says when the parity is even, it should be accepted, assuming that there is no error. So we say simple parity check method fails to detect an error when 2 bits are in error. Let us now see what happens when 3 bits are corrupted, right? So we say sender sends 10101111, but during the transmission 3 bits get corrupted, and let us say this 1 becomes 0. So now receiver will receive 11100101, but these 3 bits are in error. When this data unit is given to a parity checker will compute the parity or check the parity. As there are 5 number of ones in the received data unit, receiver there is a odd parity, and as the data unit has odd parity, this data will be correctly rejected by the receiver. So we say when 3 bits are in error, simple parity check method very correctly rejects the data. If we check simple parity check method for 4 bit error, 5 bit error, 6 bit error and so on, we can understand simple parity check method very correctly detects all the errors where odd number of bits are corrupted. So when one bit is corrupted, the error is detected. When 3 bits are corrupted, the error will be detected. When 5 bits are in error, the simple parity check method works very well. But simple parity check method fails to detect an error when even number of bits are corrupted in the received data. So this is how simple parity check method works or detects an error.